Well, hello there and welcome to northeastern Nevada, right along Highway 93 here just south of Ely. Thanks for joining me. I'm Geology Professor Shawn Willsey, and I thought we'd try something new, maybe actual video series. The more I think about it, you know, a lot of times when I go out and make videos, it's a place I've been to, I've spent some time there, I've done some work there. Or maybe it's a place that I've researched a little bit and done a little sleuthing on the internet, figure out what might be going on. But I think for a lot of us, sometimes serendipity is a great way to go about things as well. And so, wait for the truck to go by. And so I thought we'd try a new little series that I think I'm gonna call Random Road Cuts, where it might not always be a road cut, could be an outcrop, but basically just picking some place that I know very little about and then approaching it in a similar manner that you might as you're out on your little geologic explorations, trying to make heads or tails of the complexities in the natural world, just maybe working through an outcrop or a road cut together to see if we can maybe not figure it out, but at least put together some observations that warrant maybe some consideration and some scrutiny and some thinking about. So definitely as we look at road cuts, and if you're gonna get into the road cut business, make sure you're safe. I've picked a pretty obscure highway and kind of a time of day when there's not a lot of traffic. I've got a nice big pullout here, and so a safe place to park. And so I feel pretty good about getting over there and messing around and not being in danger in any way, shape, or form. So the first thing we want to do as we look at our outcrop here, our road cut, is just kind of get a big picture view of the whole thing. Like what colors do we see? What can we infer about the rocks, even though we haven't gone up there yet to discern rock types? What can we discern? And definitely one thing I see here is definitely the gray and light colors here. I see them again right here. But then as I work my way down to, I guess this would be the south end of the outcrop, the rock changes character quite a bit. This is much more cliffy and craggy on the left side. And down here on the right, it looks a lot more shattered and broken. And so let's head across the way here and see if we can just work our way from the north end down to the south end and make some observations. Will we find anything spectacular or groundbreaking? Probably not. But you know, if you're gonna work in geology, you got to kind of be willing to spend a little bit of time looking at some of the maybe seemingly less spectacular things that might seem a little more mundane. And just like anything in life, you know, honestly, this outcrop has enough exposure to it that we could probably spend, you know, hours here, right? You could really just run over this thing with a fine-tooth comb and probably find all kinds of neat little hidden gems here and there. But let's just start at this end here. It does help to know a little bit about the area you're working in. This part of Nevada, as I kind of turn back around and look to, I guess, the southwest here, this is the Schell Creek Range. And like a lot of the mountain ranges in Nevada, Paleozoic sedimentary rocks are quite common. So this part of Nevada was under the ocean for a long period of time. So as I see these gray colors in the outcrop here, even these lighter gray colors here, without even looking at the rocks, I'm sort of thinking maybe they're limestones or dolostones, carbonate rocks. Of course, we want to look at them up close to verify that, but that's, you know, that's my hypothesis right off the bat. So let's see, what can we see with these rocks? It looks like they are fairly fine-grained overall. They're very shattered. They're highly fractured. We can just see the texture of this rock, all these faces and facets running along it. Tells me this rock has been fractured by some process and broken up. Even though it's still glued together, it's been under some amount of stress at some point in its lifetime. So one of the things we can do here is try to figure out what this is made out of. Could be made out of quartz, could be made out of calcite. It looks like it's somewhat more crystalline versus clastic, so it's not made out of grains of sand or gravel as far as I can tell. And so I'm leaning towards it being a chemical sedimentary rock, possibly again a limestone or a dolostone. And one way we can differentiate those two is with our handy dandy little acid bottle. So if we use our dropper bottle of dilute hydrochloric acid, we get kind of some weak fizzing. Another way to test it would be to scratch it and then test the scratch spot to see how that reacts to the acid. And we do get a little bit more vigorous fizzing in there. It might be a little hard to see with the camera, but very kind of fine grain. I think it's safe to call this a carbonate, which would kind of be a good term that would encapsulate both limestone and dolostone. So we've got some sort of rock that was laid down under the ocean. We don't know the age, probably Paleozoic in age, because that's the common age of these carbonate rocks in Nevada. As we work our way this way, the rock actually gets a little bit more white in color, a little bit more crystalline, and again, lots of fractures. So this is a highly fractured rock unit in here. We can see, again, high degree of fracturing this way. We're just kind of working our way down the outcrop, waiting for something to change. There's an interesting line running up and down the outcrop right here that could be a fracture. Well, it is a fracture, but it could also be a fault. And notice here at the bottom, we have a definite contrast in color. The gray rocks on the right and the more whitish rocks on the left. So we've got a fault, a fracture where the rocks have moved on either side, displacing the rocks and creating this discontinuity here. We could test this gray stuff with acid. Again, it's fizzing weakly. It's not the strongest reaction I've seen, but it looks a little more vigorous than the dolostone. So I'm gonna call this a limestone, but again, I think it's safe to call these carbonates overall. Let's see what else. So looking up the hillside, we can see that changes into grays, but we've got all kinds of colors up here. We've got whites and creams and reds, all sorts of stuff happening. The presence of the fault helps us a little bit with the interpretation we had about these rocks being highly fractured. So we saw them busted up, highly fractured, shattered, if you will. Now we're seeing faults, and so that's pretty instructive as well. Right here, this little surface, I'm trying to decide, it's somewhat polished in places, and there's a hint of some lines running through it this way. Now that could either be bedding, the layering in the gray rock, or possibly if this was a fault surface, these could be what we call slicken lines, basically lines that show the movement along the fault when the rocks moved and were dragged across the fault. We can also see there's a sharp contact here between these gray rocks and these lighter colored rocks. So again, I think we have another fault running right through here. What's interesting about this surface, probably a little hard to tell on the video, is that it's a little bit, it kind of has ebbs and swales to it, kind of is wavy or corrugated, and that's a somewhat common feature in faults as well. Working our way up. Okay, another fracture or fault here, although this one's a little bit different. We can see that the fracture, this seam, has actually been filled in with white material, probably calcite. Yeah, it looks like it's fizzing pretty good there. So this would be a calcite vein. So a vein is a fracture where we get fluid moving through the rock after it's formed, and then it's precipitating out some mineral material. A lot of times you might get a quartz vein. In this case, the calcite vein makes sense, but because we have these rocks, these carbonates, limestones and dolostones, made out of calcite, and so that material has probably been dissolved out of the rocks by groundwater moving through them, moved through these fractures, and then reprecipitated. Also looks like we might have another smooth fault surface here. Move some of these out of the way. Yeah, that looks like another little fault surface there. So we can see these rocks have definitely been busted up. And then as we leave the gray rock, still moving to the south, there's a zone of the white rock in here. And we can see that this is highly busted up, what we might call brecciated. You can actually see the red material around the individual particles of carbonate rock. So this could be another fault zone where the rocks have been pulverized as they've moved across the fault and broken up to produce what we could call, at least right here locally, this could be called a breccia, because the particles are big and angular. So you might call this a carbonate breccia. And then as we move this way, the rock just looks a little bit more fractured like it did previously. Again, another zone of highly fractured rock. And then we reach another sharp contact. And this sharp contact looks like it runs quite a ways up the face. Hard to see where it goes up here, but at least from this point where I'm pointing with my rock hammer back down, looks like we have probably another fault where we've offset the layers and we've got this juxtaposition. What's also great here is if we get in close, oh, this is wonderful. You can see there's little clasts, little chunks. So again, just like we saw earlier where these rocks have been pulverized, it's broken up the rock fragments here. And in fact, I'm looking at this for the first time with you, making this up as I go a little bit. Looks a little different than the breccia we saw earlier. Some of these particles smaller, somewhat more rounded. Down here it looks more like a breccia, but this could actually be what we've seen before in other videos, a clastic dike. So this might have been where a slurry of fluid, sediment-laden fluid, moved through this fracture and deposited some of these little pebbles and particles in here. Really nice contrast here. We've got really three different rock types here with the gray carbonate, the white brecciated material, and then this possibly clastic dike, or maybe it's part of the fault zone. Can't say for sure, but definitely some neat observations right there. Again, you can just go over this thing so closely. So now we're entering a section where the gray rock seems to be more dominant. We're also getting a sense of bedding in these rocks. You can see some of the layering here tilted about like this. And then as we work our way this way down the outcrop, you can see it's actually kind of folding over. This nice smooth surface here at the bottom is the bedding surface. Then as we move a little further this way, it becomes much steeper. So very irregular bedding in here. The rock layers have definitely been folded, compressed, changed to some degree. Little different unit here with the gray. This gray carbonate, probably a limestone. And then we can see these little tension gashes in here where the rock has broken and it looks like it's been filled with calcite. If you look at this, this is crystalline material. And to double check that that's nice pure calcite, we'll hit it with some acid. Yeah, that stuff's bubbling pretty vigorously. Try this one over here. Yeah, so the rock itself looks like it's a limestone as well, as opposed to a dolostone. We get things like this. This is actually really cool, where we get some small faults. So you can see this layer here has been broken along a fault. There's another little one here. So you can see these two parallel layers here sort of step down. A lot of times if we look at the small faults and if we measure them and really sort of quantify their orientation as best we can, that's really instructive as to what's going on with the bigger structures and the larger faults. That's actually what I spent a big chunk of my graduate research doing down in Baja, was measuring small faults as a way to figure out what was going on tectonically in the big picture. Let's keep working our way across. There's a lot to digest here. Oh, slippery spot. Sorry. Back on my feet. Another fracture here. More faults. See how these two layers just terminate against this fracture? And if those two layers are the same as the ones down here, zoom out so you can see it a little bit better, then we have this side going down and this side going up. Again, we'd want to spend some time closely, figure out if that's the case. But we can see the bedding here is oriented more or less like this, horizontal, not quite horizontal, but probably dipping a little bit to the left here. Another fractured or fault surface running through here. And what's interesting here, yeah, this rock has just been beat up. As you can see, the layers bending into the fault a little bit. So here's the fault, but look at these gray and brown kind of mottled layers. As they get into the fault here, they actually deflect downward. So as this fault moved, it dragged the rocks on at least one side, possibly on both sides. So this is cool stuff. As a structural geologist, this stuff gets me pretty excited. Let's work our way across here. More gray limestone. Step across this thing. Wow. Then we get something completely different. So now we have, looking up, the gray rocks on the left, but there's another fault that's coming through here like this. And this fault looks like it was quite a bit larger than some of the other faults we've looked at, based on not just the amount of offset it likely has, but look how thick the calcite layer is along it. So it's both a fault and a vein, I suppose, because it's showing signs of movement, but it's also been filled in partially with this calcite material here. And some of this stuff's just really cool to look at. So you can see the concentric banding around the calcite here, almost like an onyx. Another little zone here, really quite colorful. This would make for a nice little specimen. Here's some more up in here, and then coming back down towards this other surface here. You can see some of the crude calcite crystals in here, some of the crystal faces, and then in other places like this surface here, it's more what we call druzy, I guess, or very fine-grained in terms of the size of the crystals. But that's fantastic. These ones over here aren't on the fault surface. These are probably cavities. So remember, limestone is a rock that can be dissolved by groundwater or even surface water that percolates downward. So that likely was a cavity, a void in the rock that was then filled in partially, well, wholly really, by these concentric bands of calcite to give it that kind of beautiful characteristic look there. Yeah, that's definitely calcite. Pretty cool. All right, let's keep moving on. So we've got a big fault here. I'll try to point this one out down from the road as well. Let's work our way down a little bit off this high shelf. So we've left this fault zone here, and we're working our way to the south. Looks like the rocks become really gray again. There's mainly the limestone, but when we look in detail, we can see there's still evidence of fracturing, smaller faults. You can see all these lines that cut through it, lots of calcite veins. Busted up, but still mostly together. Then we run into this. A nice smooth face, just coated in some orange material here. If we get up here on the side, it goes back to the gray, so you can see it's kind of a thin layer. And what do you think this is? My guess is this is probably another fault surface. It's very smooth overall. You can see how sheer it is in terms of cutting the rock, and we've had minerals move down through this, and it's just been stained probably with calcite, maybe some iron oxide that's giving it that red color there. But another big fault surface. Okay, so let's move down, back down to road level and finish up this video looking at what we saw at the south end of the outcrop or road cut, which was the rocks that were not making cliffs. They look really shattered and busted up. You know, this stuff looked pretty competent, and it's making cliffs, but as we inspected it closely, we saw that it was actually pretty busted up. So quick overview, we started down here, worked our way kind of up through this area. One fault right there that we looked at. Then right here was that big fault with the banded, almost onyx looking calcite mineralization. And then our next big fault here with the orange staining. And then we just came back down along the road here. So it looks like more of the carbonate, but I want to get into this next section of rock and see what we can infer there. Lots of calcite veins cutting through this little section here. So the veins imply both fracturing and fluid migration through the rock. So now we're seeing something quite a bit different. The big cliff units are kind of gone. And now as we look at this material, let's pick up a piece or two. It's a little bit shiny, more fine-grained. Let's see if I can do this with one hand here. If we put a little drop of our handy-dandy acid on it. Yeah, really no reaction, although we are getting a little bit of reaction along some of these little lines. So those little thin lines crisscrossing it are probably more little calcite veins. But what is going on? So this, what would we call this? It's fine-grained. It's definitely breaking in thin sheet-like layers. And so I think calling it a shale would seem appropriate. However, as I'm looking at some of these, they do have a little bit of a sheen to them, just a little glossy sheen, as if it has very fine mica crystals in it. And so this rock is fundamentally sedimentary, but with that glossy sheen, what that's telling me is that it's been slightly, ever so slightly metamorphosed. It's probably just been buried deep enough or squished enough that it's been heated up, and some of those mud minerals, clay minerals, have been metamorphosed into micas. So we might call this a phyllite. And really, you know, in the field, it's sometimes tricky. You'd be better off maybe just calling it a fine-grained, layered, you know, maybe proto-sedimentary rock if you weren't sure exactly what to call it. But as we look up here, remember this rock has a lot of layering to it. What do you see going on with the layering right here? Are you seeing what I'm seeing? There's actually a nice fold right here. So this rock layer right here has been folded, and there's a little bit of a kink fold, a little kind of like an A-frame tent right here. So there's a little anticline in this spot, a little syncline here. We can see that running up through the rock. In fact, these smooth places are where the bedding surface is sort of facing us. Oh, there's some more beautiful ones. Wow, what a gem. What a great random road cut. So here's another sort of fold. Let me try it with my other hand here. This fold sitting in here about like that. So there's rock layer folded there. And you're probably seeing a lot more than I am because you're sitting there on your computer scrutinizing it, or on your phone, your tablet, whatever, looking at it in some detail. So it looks like, oh, another great one here. Another nice fold here. So these originally horizontal sedimentary beds of shale have been very tightly folded, busted up. I mean, it's sort of a wonder. I guess the road cut probably helped expose these. This would not probably reveal this much rock if it was on a hillside, but cutting the road in here expose these nicely. And then up above, we have the same carbonates that we did back at the beginning. So unless these rocks are flipped over, which is possible, this would be an older unit if everything's still right side up. So these shales or phyllites, you know, they might have, we probably won't take the time to look in here, but knowing the age and this rock type could have fossils in them. Good chance they do. If I see one, I'll let you know, of course, but we'll have to see. And then let's finish up maybe by looking maybe up here. This little interesting slabby feature. Yeah, shale has this kind of interesting sound to it. Well, this is really cool here. Holy cow. So what we have here is a layer of the shale right here with my hand on top, this layer right here. But on the side, the layers are oriented almost vertically. So either this is a really tight fold, but because they don't really match up here, see how there's like a big crack separating the two right here? My guess is that they've actually broken in this case. Sorry about the bad videography. I'm trying to stand on the slope. Probably what's happened here is these layers here have been shoved up over the top of these layers. So this is the small fault, what we might call a thrust fault. So remember, these rock layers will bend, but only to a point. At some stress level, these folds can only be so tight because the rocks are pliable to some degree when the folding's taking place because it's underground, but at some point they're also brittle and they'll break. So this layer here looks like it's been pushed over the top of this layer and producing this thrust fault here. So we have nearly vertical or steeply dipping beds below the fault in what we would call the footwall, and more gently, I guess, northeast dipping beds up above it in what we would call the hanging wall of the fault. What a gem. Just all sorts of cool relationships in here that you can scrutinize. So this was a long video. Maybe you stuck with me, maybe you didn't, but hopefully this maybe helps you a little bit as you're making observations, as you're exploring your neck of the woods and the cool earth features that might be in your area. So yeah, let's walk down just a little further here and we'll wrap it up. This road cut goes on for quite a ways, and it doesn't look like it changes demonstrably in terms of its characteristics from here to there. Wow, look at the folds in here. Tremendous. Hopefully you can see right in here just some of this, the swirls and patterns. If you're seeing some of these swirls and patterns, you're seeing some of this complex folding that's taken place in this unit, in this shale. Oh, this is really cool. Wow. So this big smooth slab almost looks like, if I didn't know better, I've seen textures like that in lava flows. That's actually the bedding surface. So the rock layers have gone from tilted like this to actually more or less being right here parallel to the road cut. But you can see them bending and draping over. It almost looks like it's like a folded rug or wrinkled rug or carpet frozen in time. And you sometimes see this ropey characteristic with lava flows, pahoehoe flows, but in this case it's actually sedimentary units, shales, and not basalt or lava. So pretty awesome. All right, I hope you enjoyed that. Let me know what you think. Are these random road cut videos fun and worth it, or are they a waste of time? Let me know. I don't have a preference either way, but I think it's kind of fun exploring a road cut that I haven't really been to with you together, or someplace I know little or nothing about, and then just kind of working through it and being surprised together. That's kind of a nice, I guess a nice diversion from what I normally do, which is, you know, I know a little bit about the location, or I've done a little bit of research, so I'm kind of going in with a script and a plan in mind to show you. But this is much more impromptu and much more on the fly, as you will. But hopefully you found it entertaining. I'm sure the videography was iffy in some places. But thanks again for joining me, Geology Professor Shawn Willsey, at a random road cut in northeastern Nevada. If you like this stuff, please like, share, subscribe. You can also help me out by donating to the cause. There's a donate button on the banner of my homepage. There's also a thanks button to the bottom right of the viewer. And under all the video descriptions, there's a PayPal link. So anything you do to help me will help me just get out and make more videos, which is enriching to all of us. So thanks again from northeastern Nevada and our first random road cut.